Warm-up problem number 1. With the switch closed, the Kirchhoff's voltage law equation says that 15 volts is equal to 4 times the current from the source, call this I sub S, plus the voltage drop across the inductor. But a voltage drop across the inductor is the same as L di dt, where I would be the current through the inductor, and that's what we're trying to find, the value of the current at steady state. Well, in steady state, di dt is not changing. That's the definition of steady state. Nothing is changing. If that's the case, then this term goes to 0, and we can solve for I sub S then as being equal to 15 over 4 amps. So the current is coming out of here, and it's going through the inductor, going back in this path, because this now appears to be a short circuit in steady state. Now, what happens if the switch were opened? Well, if we open the switch, the circuit in here will have some initial current flowing in the inductor, but it will eventually dissipate through the resistance 8, through the 8 ohm resistor, and so we'll find that the current through the inductor in steady state at infinity, when the switch is open, would approach 0 amps. And this is the value of the current in steady state through the inductor when we start off by closing the switch. So with a switch closed, steady state goes to this. With a switch open, steady state, the current goes to 0. Now, problem number 2 is exactly the same as problem number 1, except we replace the inductance by a capacitance, and we ask basically the same question, except now we're looking at capacitance voltage. Now, with the switch closed, so imagine the switch is closed, what happens to the capacitor voltage? Well, with the switch closed, current would flow into the capacitor and would charge this capacitor up to some value, then it will stop at that point. At what value will that happen? Well, if we look back into this network from the capacitor's point of view, looking back this way, we're seeing essentially a voltage divider. We're seeing a 15 volt supply, 4 ohms and 8 ohms. Consequently, the voltage across the 8 ohm resistor would be 8 over 8 plus 4 by voltage divider action times 15. And that gives us 8 over 12, or 2/3, and 2/3 of 15 is 10 volts. So this capacitor will charge up to a value of 10 volts in steady state. Now, what happens if the switch were open? If the switch were open, the capacitor would be discharging now through the resistor, and in steady state, all the charge will drift from the capacitor, and so in steady state, the capacitance voltage would go down to a value of 0 volts. This will discharge completely, and you'll have 0 volts. So the first part, the answer is 10 volts, and the second part, with a switch open, the capacitor will discharge to a value of 0 volts.